Hello everyone and welcome to this new CATIA Design Talk, the webinar series where we explore the latest trend, tools and techniques in industrial design and engineering using CATIA, the world-leading software for product development and innovation. My name is Fabio Ballari and I have the pleasure of hosting two CATIA experts who will share their insight and best practices with us. So welcome to Felix, ROCKEL and Edouard, SUTRE.
Hello.
Hello.
Welcome.
Hi guys.
Hello
Hi.
everyone.
So over the years, we have observed incremental advancement in visual programming languages and graphical algorithm editors. For those of you that are not familiar with this capability allows designer, architects, engineer to create and manipulate complex 3D model by visually connecting different components called node operators in a flowchart-like interface. Last November, we have introduced CATIA Visual Scripting within 3D Experience. This provides a flexible, intuitive way to generate, control, and manipulate geometry, parametric design, and data-driven model. So Felix, can you give us an introduction of this incredible app?
Yes, of course. So I hope everybody can see my screen, right? Fabio, thanks for this introduction. Yes, CATIA Visual Scripting on the 3D Experience platform, as mentioned, it's quite new, has been released with our 23X version. And what can we actually do with this application? We can generatively produce structures and patterns that have a certain dynamic to it. So not just stiff patterns, I would say. Regular patterns, we can create dynamic, irregular patterns and structures with the application. So here you see some example out of the product design world or automotive examples, and also in aerospace, in the structures below the main surfaces, we can create those structures. So yeah, here again, product design example, or this also has been produced with visual scripting. And yeah, here you already see the example of the graph edit, or an example of the graph editor. That's how you actually produce those algorithms for those patterns and structures. You have those operators that you connect with each other in order to produce those algorithms. Some other examples of structures that you can produce with the application. Also one example out of the architecture world, and another example of the product design world. Here we have also the first glimpse of a new capability that we have in visual scripting. That's the meshing operators, and Edouard has prepared a very interesting example that he will showcase after my demonstration. All right, the visual scripting application. So for whom was it actually built? So creative designers, for product design, automotive design, architects, but also in mechanical design, like with these escalators. You can use visual scripting, or patterns from visual scripting are found. Once you launch the application in the 3D Experience platform, you get a new node in your scene tree. And with this new node, you have access to this graph editor, where you can then generate your algorithms with these operators. But you will see this in a second in a little live demo of myself. Here's some examples of the graph together with the structure that can be produced with it. Also, after closing the graph, you have still access through the scene tree to all the main parameters, and you can play with the parameters to generate different outcomes. You see here the size of these holes and the amount, for example. And also you can capture and reuse content. So if you have a quite complex graph, you can combine this complex graph into one new node and create a new node out of it, and then share this new node with your ecosystem. So like this, through the platform, you could have a department or group of super skilled experts, and they share very complex operators with your ecosystem, maybe with the designers that might not be such experts in the application themselves, but they can reuse those operators, just assign them on any surface that they produce with CATIA on the platform, and then play with the parameters in order to find the perfect pattern for each shape. And what I'm about to show right now, I think, is very important in general on the 3D Experience platform, that the power is really the combination of all the applications that we have. So, for example, you could start in a workflow on the 3D Experience platform with really any surfacing application out of CATIA. So let's say imagine and shape subdivision surface or parametric surface from GST, or could also be a Bezier surface from IDX, and then create your pattern on top of this input surface, and then maybe visualize your result in live rendering, your pattern that you have created. You could also review it in VR at any time, and then you have access, of course, afterwards to all the downstream processes in CATIA, all the analysis features, the surface refinement features, to produce high-end surface results, to make your pattern and your surfaces then manufacturable. And this workflow, actually, I would like to introduce you now in a little live demo.
All right.
So let me switch to the 3D Experience platform. So here you see just one example of a concept model that I did together with my colleague Andras Stojanovic. So we collaborated through the platform a lot in order to produce this. And you can see here that here we generated this pattern with visual scripting. It even has fillets directly created in visual scripting, something that we are pretty proud of, that we can do that directly inside this application and that we don't have to do it manually afterwards. Also, this pattern here on the rear cover has been created with visual scripting, and also the rear lights. And of course, for the interior here is not so detailed, but there are many occasions where you can use visual scripting to produce nice patterns. Maybe the outlets for the loudspeakers would be one very typical example. But okay, I would like to show you now how to start from scratch and produce such patterns with visual scripting. So let me just create a new product and then insert a 3D shape. That. Just open it. Okay, so I will start in Imagine and Shape and generate a subdivision surface as my main input. This could be as mentioned before. This could be really any shape coming from any CATIA application. So in this example, use just a subdivision surface from Imagine and Shape, and I will add some cuts and make sure that the surface has a certain dynamic, so it's not just a plain boring surface, because I don't think that this would make a great example. So it doesn't actually matter how this surface is shaped, just to have something interesting. Okay, so I think we can go with that. Let me just quickly change the ambience so you can maybe see better. And I think I should also, in the view notes, show all my wires and points. Okay, so now I'm in Imagine in Shape, and then on the platform I can switch in CATIA very quickly between the different applications. So now I'm in the Visual Scripting. I have assigned a keyboard shortcut to switch between applications, so I can switch back and forth very easily. Now I go to the Visual Scripting tab and create this design sequence, which will open then my graph editor or give me access to this graph editor. Okay, the first operator that we need to create is input operator, an input operator. And with this, we can select, like I said, really any surface, any object, basically, could also be a curve or point, and have it then in our graph. And then we will create now something quick and easy. Triangulate, and it needs just a length. So let's start maybe with, let's say, 30 millimeter. See what kind of result there could be. A bit higher. Okay, like that. And then I can create a fill there. And if I hide here my input, you can see that I've sort of triangulated my surface. I can then create a parallel curve, and you see here with the color coding that with the orange, it's telling me that it needs another input in order to produce the result. So it needs a surface as input, and 20 millimeter is way too big. So 2 millimeter offset. So that create now this parallel curve, and then I can create a fill from there and maybe hide my first one. So yeah, I've already generated a structure or a pattern, very quick and simple, but let's make it a bit more interesting. Let's create something a bit more dynamic. So what I will do is I will create a bounding box. So it creates a box around my input. And then I want to have the sub-elements. So if I hide it, you see that the result of it gives me an R by default, the edges, but actually I want to have the faces. And here you see that it produces now a list out of the 6 faces that I have here. So I want to have just a certain one. So I need the get item operator, and I need to get a true value here as input. If I hide this, you see here now that I can select out of the 6 results which one I want to use. So let's stick with this for now. Here I can then set center points out of each triangle, like that. And then I can measure the distance between each center point and the surface, the face here. And this will give me again a list of results, with values that are a bit too high at the moment to use as my offsets, but I can divide them just by any value. Let's say 50 for now. Let's see what kind of result this gives us. Looks okay. So I use this now as my offset. And yeah, of course, you see now that the further the triangles or the center points of the triangles are away, the bigger the offset is. And I can switch that here, of course. So if I have a different input phase, I get a different result because it's measuring now from here.
That's incredible how many variants you can do in very few time. This can also inspire designers.
Absolutely. So In the end, the only thing I need to do is maybe assemble this. And then I can even generate volumes out of this. Thickened surface, by default, the offset is a bit high, so I will decrease it. And then this is important. In the end, you always need a publish node to retrieve your geometry outside of the graph. So once I have this, I can close the graph, and yeah, you see my result right here. Let me go back to the darker view. With a double click, I switch the application again to live rendering on the top node, and I can create and apply material. So let's say this could be a real light. So I can assign a glowing material and then change the color to red, maybe, as it should be a rear light. And yeah, here you see my result. But thanks for being in CATIA, I can of course switch back to my input surface and then reshape as I like. I don't know, maybe like that. And validate, and instantly my pattern will be applied to the new shape of the surface.
All right. That's huge. How many variants you can do in quick way, avoiding all details, do it manually, you know?
Yeah, absolutely. And I'm a designer myself. I have to say that this is it was a very new for me, for someone that was just used to generate 3D geometry in the regular way, I would say, in the old school way, to generate it now with this operator approach and this graph editor. But once you get the hang of it, once you understand the mechanics, it's so much fun to produce patterns like this. So I really enjoy this application a lot.
Okay, so I guess, Edouard, you have another example to show to us today.
Yes, of course. So for the end of this live, I would like to show you our latest demonstration, so through a video. Here is to show you a new creative seat project in the 3D Experience platform. We start by just using, creative design experience application to create the initial shape of the seat, okay? And then we would like to show you how we can use Visual Scripting app in order to accelerate or to add a lot of details into any shape, in fact, to help the modelers by reusing templates. So here, what I'm doing is, in fact, I'm converting the subdivision surface into a mesh element. And now in Visual Scripting, we are able to manipulate meshes to deform them according to different additional operators. What is also very nice, we have introduced a physics engine in order to deform meshes. So here I'm creating a list of constraints like pressure, elasticity, and we can now run a soft body simulation on top of the mesh in order to deform it a little bit according to some constraints. So here you can see I'm trying to put a pressure, but also to, in fact, have a kind of little deformation due to the laser I will use as a material for my shape. Again, we are using, in fact, the algorithmic approach here with some parameters. So we can iterate a lot and deform automatically the shape according to some conditions. Then we are creating a subdivision surface from this mesh. And again, you can continue the process in the 3D Experience platform. The second step was to create another algorithm here to automate, the parting process. So from a single shape, I would like to create multiple parts to split, in fact, this shape into multiple physical parts at the end in order to add some details and also to be more realistic to the end product. Again, we are using the new mesh modeling operators here to manipulate meshes, to remove some faces or to add some edge loops, or in fact also to create additional faces using the new mesh extrude boundary operator. here I'm creating, the little details when you have to close the different laser parts in order to create a kind of interface between them. So again, I'm preparing an algorithm, but the end of it is to be reusable for any other context. And in addition, I've created a third algorithm. Here is to generate stitching on top of any shape. So my input is just a curve, and I'm creating with different operators, geometrical operators, simple geometries, prismatic geometries. And again, I will use the new mesh modeling capabilities to convert prismatic shapes into mesh elements and faces in order to, thanks to the subdivision process, obtain rounded shapes right quickly without having to create exact surfaces. For stitching, it's not really useful to create exact geometries. We just want to have 3D details. And finally, what I'm doing is to create a template. So I'm using here power copy definition in CATIA. And now any modeler can reinstantiate the available power copies of the database. So here you can see the modeler just has a simplified interface to reuse an existing template. It just has to select a curve and to change some values, and the stitching will be automatically generated on top of this model. I've prepared, in fact, 3 power copies, one to deform the mesh, a second one to do the parting process, and a third one to do the stitching. And I was able to reuse the 3 power copies on top of any new shapes in order to put a lot of details on my model in a few minutes. Here we are in the 3D Experience platform, so I can also switch to live rendering, like Felix was showing just before, create materials, put a lot of materials quickly on my model, and in one click, I can perform ray tracing images just to have, a kind of preview of what will be my product. But what is really nice, in fact, I'm still in my design environment. I can go back, change parameters, and do this iterative process. What was also really nice was to use 2 interesting capabilities in visual scripting: the unfold operator to unfold any 3D surface on a plane, and the nesting operator to find the optimized layout of the unfold parts, in order to prepare a little bit the manufacturing process and to be sure that, okay, we will not lose material. Finally, what was also interesting in the 3D Experience platform, we can have access to CATIA Human Design application in order to have a flexible virtual mannequin, really easy to use. And for the designers, it's perfect because they can just challenge their design, find some, mistakes of the design. At any time, we can go back to the initial subdivision surface, modify it a little bit. And because everything with visual scripting was, in fact, associative and parametric, we can recompute all the different algorithms. So here you can see the new shape, the new deformation, the new parting, the new stitching automatically.
Okay,
so this, sorry, Fabio. Yes, this approach, in fact, is really powerful also to gain a lot of time when you have to do a lot of details quickly in order to reach this kind of realism for concept design.
So you do it once, you apply on any design in your company, right?
Yes, exactly. This is the goal of this demonstration.
That's incredible. Okay, so now I understand better why visual programming language has gained popularity in such a field, design, engineering, architecture, because it really facilitates generative and parametric design, complex shape, automate repetitive tasks, generate complex pattern in a very efficient way. Okay, good. Thank you, guys. So in summary, visual scripting is a powerful visual programming hub, right, that extend the capability of CATIA into the experience, and also allow the user to manipulate and complex 3D model through visual interface. That's incredible. So I think it's now time to open the Q&A session. So while you're showing some picture, maybe I can open the session, and please to the audience. Type your question in the comment tab and we will answer to them.
And thanks a lot. I was able to read a lot of good and positive feedbacks too. So
okay. So is there any questions? Okay, one question. Can you generate fillet directly inside Visual Scripting, or do they have to be assigned manually afterwards in CATIA? I think this question is for you, Edouard, or Felix.
So in fact, Felix, I think you were talking about fillets during your demonstrations. In fact, what is really nice, Visual Scripting is based on the same engine, geometrical engine, as traditional CATIA applications like generative shape design, GSD, or part design. So in fact, we directly take benefit of the most powerful features of CATIA, and of course, the fillet is part of it. So fillet operator is available in Visual Scripting, and you can, in fact, now use fillet directly with this algorithmic approach. So we have the edge fillet and the shape fillet operators available in the solution. So no more, the need to do the filleting process manually, click by click, edge by edge now.
Yeah. So this could be used by any 3D modeler, actually, right?
Yeah, of course, yeah.
To accelerate the design process creation. Okay. Any other questions? Which role with the platform do you need for Visual Scripting?
So the role containing Visual Scripting app is called Visual Script Designer. It's a role dedicated, in fact, to Visual Scripting application. And what is also really interesting is you can combine the roles. So for a user with Visual Script Designer role plus, for example, industrial designer, a traditional role to do concept modeling, you will benefit of new additional operators, like, all the mesh modeling operators, but also advanced surfacing capabilities. So we have this strategy with this role is to, in fact, be able to enrich the initial content of Visual Script Designer by additional operators.
Okay. So I can imagine the list of operators is growing and growing.
Yeah, actually, we have more than 300 operators available.
Okay.
In the default product, and more than maybe 50 additional operators, depending to some roles.
Okay.
Yeah, and we will develop further and further, right? So I'm assuming with each release there will be new operators coming, also based on the feedback we get now from all the customers.
Exactly.
So combining all those operators, how many usage and use case we can create and invent. Okay, is there any other question from the audience? Are the section creating in Visual Scripting fully compatible with all the other surfaces and feature of CATIA?
So yeah, what I was explaining that we are using the same geometrical engine, so it's another benefit. You can use any geometry as input, but also the output of Visual Scripting are fully reusable, in traditional applications. Like if you produce a surface, you can then reuse this surface in part design to do a stick surface, or you can split it in generative shape design. There is a full compatibility, of the data to continue the process with traditional applications.
Yeah.
Okay.
And you can really apply each CATIA feature on top of those patterns and structures you created in Visual Scripting.
Okay. Thank you. So I think we are running out of time. So let's conclude. Thank you for joining us today for the CATIA Design Talk. A special thank you to our guests, Felix and Edouard, for sharing their expertise and insight with us. So we hope you found this webinar informative and engaging, and has inspired you to explore new possibilities in industrial design and engineering using CATIA. Remember, you can watch the replay of this talk in our CATIA Creative Design and Styling community and continue the conversation with Felix and Edouard and other experts in the field Simply register for our community and gain access to a wealth of insight and best practice, and it's free. So we appreciate your participation and feedback. We look forward to seeing you again at our next CATIA Design Talk. Until then, have a great day and keep innovating with CATIA. Goodbye.
Bye-bye.
Bye, everyone.